This is David, the Atari 8-bit podcast.
This is Antic, the Atari 8-bit podcast. I'm Kay Savitz. Listener Paul Somerfeldt sent me a blurb he found in a book called The Dobsonian Telescope by David Kriege and Richard Berry. The book reads, "Computer-controlled Dobsonian telescopes entered amateur astronomy in the late 1980s. An outstanding early example was David Gedalia's 10-inch f4.5 Dobsonian driven by an Atari 800XL computer, shown at the 1987 Riverside Telescope Makers Conference. With the Atari driving altitude and azimuth stepper motors, the telescope would move automatically to coordinates entered on the computer's keyboard. David was a third-year engineering student when he built this telescope. I sought out David to find out more about his Atari-controlled telescope. This interview took place on May 29th, 2020.
So astronomy goes way back to my childhood. I was always interested in astronomy, just really never was active in it to the point of, being very involved. I used to read books, maybe go out and watch the night sky, but was really nothing more than maybe a pair of binoculars. And I think at one point I did have like a small gizmo telescope that didn't really show anything. But somewhat in my teenage years, I started to get a little bit more interested, and I decided that I was going to actually build a telescope. I was very interested in the bigger aperture. And so instead of sort of going by steps, I just decided, well, I'm just going to take the full plunge and build a 10-inch telescope. I had really no prior experience in building this, but there was plenty of material and, some magazines and books around. So read a little bit of that, and then I decided not to make my own optics. That was just a little bit too much. I was really not into making the optics. So I purchased some of the parts, and my dad was a cabinet maker, so I had access to a wood shop. So the telescope, for the most part, was built out of wood, and it's kind of like a nice finished wood, all oak and everything. So it was a little bit more a step above the kind of like the average homemade telescope at the time. And I was probably, I think I was like a junior in high school or somewhere around that time frame. And then I was exposed to a telescope at one point. I'm trying to think. It was in a star party that I went to. It happens to be that's a story within a story, but I own this telescope now. But anyways, it was a beautiful trailer-mounted telescope that had a pretty sophisticated, for the time, computer control system that was controlled by, I believe it was an Apple II computer, but it had very expensive drive system. I think they used cards, motion control cards that were used for the movie industry. I believe that's where the hardware came from. The guy who built it had access to some of that stuff, and so anyways, that was sort of an inspiration to see a telescope that was moving under computer control, and that sort of started the whole process of what can I do myself. Here I have a wooden built telescope that's very simple. Didn't spend a lot of money on it. I think I was a senior in high school at that time. I didn't really have any budget or anything to allocate to this. But I did have an Atari computer, and I do not recall at what point I did discover that the joystick port could be programmed as an output port, not just as an input port. And I don't remember how exactly I came upon it, but as soon as I discovered that, I realized, boy, I can build something out of this, because now I can actually have some output out of the Atari. And I had an Atari 1200, I believe. Mm-hmm. And the reason why I'm not recalling quite, because I went through two other computers later on, because I ended up burning the ports. But I think the initial computer was an Atari 1200 that I had. So that kind of started the process. I had to learn about stepper motors and to build some circuits to drive them. And from there on, it kind of progressed.
Nice. So, yeah, you use the joystick port to drive the system. And so what did the computer have to know about the world in order to track a celestial object?
Right. So because this was an alt-azimuth telescope, as not like a conventional, what we call an equatorial platform or equatorial telescope that actually, where the polar axis is lined up with the axis of the Earth. An alt-azimuth is just an altitude and azimuth coordinates. So one of the first things that needed to happen, well, in software needed to know several things. It needed to know the position that it was on the Earth. And of course, we didn't have any GPSs or anything at the time. So it was actually taken from a map and very much guesstimated maybe to the nearest arc minute or something as to where I was on the Earth. And then it needed to know the local time, and I needed to level the telescope. Okay, so these are the three things that I initially needed to do. Mm-hmm. Now, there were several routines within the software that I wrote in order to transfer those coordinates or do a coordinate transformation from azimuth altitude to equatorial coordinates. So it had to compute the local sidereal time and then the Julian date, and I'm trying to recall, there was a couple of other things. And again, all these routines were kind of put together from things that I read. I didn't come up necessarily with the equations, but I had to put everything into a program. So everything was within that program that I wrote as far as this whole transformation before we could even make the telescope move anywhere. I'm trying to think about what else was in there. I think that's all one had to input is the position initially the position on the Earth, the current time, and I had to level the telescope. And yeah, that's pretty much it.
Did you write this in the basic programming language?
Yeah, so this is where the complexity of the project kind of took me a long time to figure out. So when I first wrote so discovering that I had an output port from the Atari was like, that was like a game changer right there. So I think if I recall correctly, I did build a very simple stepper driver and I drove it through that port and it worked. Boy, you could see the motors moving. The problem is that it moved fairly slow, even at the highest speed. So I wrote a 4-next routine, and just a stepper motor has 4 phases. So you basically have to sequentially run each phase on and off. And so when you run that, the motor did run, but I kind of don't remember exactly how many steps per second I was getting, but it really just wasn't fast enough because I calculated approximately the reduction gears that I would need to have in order to make the telescope, slew of the sky with certain resolutions to have some slow motion controls. And it turned out that my slewing rate at that point, if I were to drive the telescope using that method, it was going to take anywhere, I think, I don't remember exactly, but something in the order of 4 or 5 minutes to actually go from from 180-degree slew, which is the longest slew I needed to do. And that just sounded way too long. That kind of defeated the purpose of having a computer control. If one has to sit there and just kind of wait for the telescope to move and it's no fun, it's no fun to see a telescope slew like that. So that's when I had to dig a lot deeper, certainly much more knowledge than I had. I mean, I had very good understanding of BASIC. I wrote quite a few programs for Atari, all kinds of graphics things. But besides the BASIC, I really didn't understand the next level down, which was assembly language. But I had to start digging into that because I figured that that's my only way to implement this routine to run much faster. And so what I didn't have is an assembler editor at the time. And so what I did, I recall Atari Basic pretty good, there was a method of poking the machine language directly into memory. Mm-hmm. So you could write it all, and then you can do a 4-next poke routine for an entire set of memory. There was I don't remember exactly, it was a long time ago, but there was a memory set that was allocated that was free memory that you could poke a machine language program into. And so that's what I did. Of course, I'm saying this right now. This took months to develop because I really didn't know what I was doing exactly at the beginning. But once I kind of started to understand this machine language, I developed this routine, and I was able to poke this into memory and test it a few times. And of course, through some iterations of cleaning it out, I was able to run the motors through machine language, and that made a huge difference, because that was a 6502 machine language routine that ran the motors, and they were really flying at that point. What I did discover, I remember this vividly, is that I actually had to turn off the screen refresh interrupt. So when the telescope was slewing, what I ended up doing is I had a blank screen, because the screen interrupt would slow down, that program. And
right,
so when I did that, right.
Yeah, get more processing power with the screen off.
Exactly.
Yeah. Interesting. Was the screen an issue when you're out there looking at the stars anyway? You probably didn't want a bright screen messing with your eyes anyway.
No, I did have a small, I think it was a 5 or a 6-inch, one of those 12-volt DC TVs. Running this thing in the field was a whole thing in itself, because I had a little inverter that was probably a square wave. I don't know where I got it from. It was very old. It made kind of a buzzing noise, but it kind of worked. Later on, I discovered, though, that I can, even though I think the power supply, if I remember correctly, was 9 volts AC, but somebody that I knew, an engineering friend or something, said you could plug the computer directly into 12-volt DC and it'll work. And my heart sank when I tried that the first time, but lo and behold, it did. So I remember running it directly from 12-volt DC afterwards. I did have a disk drive that didn't like the 12 volts, so I did have to run it off an inverter. But I remember having one of those small DC TVs that I had with me. Yeah, the screen was kept pretty dim. And then later on, one of the problems that I had with this whole program is that I ran out of memory. 64K was just not enough to put everything that I really wanted to put in, because I wanted to create a database of some of the more, bright objects that are viewed on a more routine basis, like the Messier catalog and some of the brighter NGC objects. But I wasn't able to do that. I was able to put, I think, a few in, but pretty soon I just ran out of that memory and just couldn't do much more with a program.
Interesting. You said you might have burnt out a couple of computers with this project. What happened?
Yeah, so I didn't have any. Later on, I think I did put some optical isolators on the output, but I didn't have any isolators. And I think through just, pure, messing around with the circuitry, I know I burned the output of one of the ports on my initial Atari 1200. And at that point, that wasn't initially actually when I developed the system. That was later on when I was tinkering with some other things. I think it was maybe, a year or two later after I got the system working. But I remember I burned one port and I had to go purchase another Atari. Now, at that point, there were some used ones available on the market, and that's where I purchased one. I think it was through local paper, what would be today's recycler or something. Right. I don't remember what it was.
Some sort of classified ad situation.
Right. Yeah, yes. So I think I purchased 2 of them at the time just to have one extra. As one of them was an 800 XL, and I don't remember, maybe it was another 1200, something like that.
It just seems like a lot of gear to cart out to a field somewhere. You've got the telescope and the computer and the powering and the monitors, but I'm glad it worked for you. That's great.
Yeah, it was the telescope, the computer, and the disk drive to load the program on, small TV, and then I built this small interface box that connected to the telescope. But it did work. What I didn't have computing power to do is to actually track, so real-time computations of the movement, and actually make the motors, track at, because the rate varies depending on where the object is with an alt-azimuth mount, depending on where you're pointed and where the object is in the sky. Both the azimuth and altitude have to be driven together, and it's a varying speed. So I couldn't really get that level of software to even begin run a program like that. I simply didn't have just the computing power or the memory. But what I did implement, which was kind of very cool. Some folks thought it was really ingenious because when I let other people look through the eyepiece. So when you look through a normal telescope, the object slowly drifts away from the field of view. You center it, and then depending on the magnification that you're looking at, the object starts drifting towards the edge of the field. Well, what I did is I put a button on my control paddle, and when you pressed it, it basically ran a calculation of the new position and would do a very short slew and just recenter the object. So rather than have a continuous tracking routine, I simply was able to recenter the object, which was really cool for other people when I wanted to let them observe through. Just hand them the paddle, and as soon as the object has drifted enough, push that button, it'll be recentered. So it was kind of fun.
How cool. Neat. So what did your astronomy nerd friends think of this when you took it to shows like the Telescope Makers Conference?
Yeah, so I did not expect the reaction that I did. I kind of remember that that event was from Friday through Friday morning through Monday morning. And there was it's kind of a campground, it's I think it was a Boy Scout camp or something. But when I set up the telescope, I had so many people around me, and I didn't expect the attention I was getting. And it was, I think for many people, it was probably the first time that they've seen, a telescope move under computer control, and certainly not something this simple. Observatories had that, and universities had that, and I think some really, big firms, maybe some amateurs like the telescopes that I've seen before, who really had deep pockets and other means to implement something like that. But for me, it was a very simple system. I already had the computer, in existence. I put together some circuits. I think I bought my motors surplus. All the gears came from surplus places. There was a local kind of a junkyard, if you will, for this, surplus mechanical parts. That's really where it all came from. And so it was kind of neat to see a system that was really, I think what attracted most folks is that the fact that it was very inexpensive for me to build it, but it worked, and it really worked very well.
Nice. So do you still have the code or the equipment or any of this stuff?
No, so I thought I had, I might still, we moved like 3 or 4 years ago, and I don't know if I got rid of it or not. I know the circuitry up to about 2 years ago I had it, and I finally had to get rid of it. I did take a few pictures of it before I tossed it, but it was all obsolete. The telescope itself, parts were utilized for the telescope for other projects, so eventually it all came apart. I still think I have the optics somewhere from the original telescope, but the motors I used for another system that I built, not necessarily with an Atari, and then some of the hardware just kind of basically got fragmented to different projects.
Sure. Cool. Well, if you ever find any of the code on printed out or on floppy disks or anything, let me know. And I'm sure that some of the people in the Atari community would love to see how you did what you did.
Sure.
Yeah. You mentioned you did some other Atari projects. Can you remember any of those?
Oh, I don't know. I used to mess around a lot with the Atari early on. I used to write all kinds of stuff. I think I wrote a program that simulated a slot machine. I think my family members thought that was the coolest thing. Or I did write a blackjack program, and that was pretty good. I don't know if any that existed at the time, but that was actually just completely from scratch. Just rudimentary graphics and maybe some other games I can't remember, but used to play a lot with it. Mm-hmm. I kind of wish I did keep my machine. I don't know what happened. I think at one point I sold my computer, and I had a printer, an Atari printer, and the disk drive. That was many, many years ago. I think I sold in the garage sale or something. Sure. But I think if I sat in front of an Atari, I could probably remember some stuff. All the graphics. Graphics 8, I remember, was like a high resolution graphics or something.
That's right.
But yeah, I remember some of that. Right. Yeah, I could probably write a quick program. It's really cool. That's really where I learned, computers and stuff.
Cool. Were you aware that you had been written up in this book that we found?
Not in this specific book, but the author for that book, Richard Berry, I was featured in Astronomy magazine for every year they used to cover that astronomy convention. So there was some pictures there of the system.
Oh, cool.
And it was covered there. And then there was another book that was published, I think it was called New Horizons for Amateur Astronomy. And there's actually a half a chapter there dedicated to my system at the time.
Are you still into astronomy today?
Yes, very much so. Yeah. A lot of the equipment nowadays is, run-of-the-mill computer control. I mean, that's just almost standard with many of the telescopes that are sold. And the equipment has got so much more reliable, of course, so much more compact and, much more sophisticated than simply just, slewing the telescope. So there's routines that correct for mount inaccuracies, and they model actually the whole mount. And there's a lot of complexity that goes into the programming of today's computer-controlled telescopes, but it all started at one point, right?
Right. Cool. What haven't I asked you about that time that I should have?
Oh, well, let me see. So, it was basically a solo project. So, I really didn't have any outside help from anybody. I remember sitting until 2, 3 in the morning, trying to figure out some of these routines. And so I kind of feel proud that I developed both, the hardware, the software, and integration with the telescope. And it was really a solo project that I did all by myself. So it was a little hard at the time because when you had a question and when you had something come up, it wasn't as easily as today when you go on a forum and you can ask a question or you can just search the internet. It was just that availability of knowledge was just not there. I just basically had a couple of books, one about, I think I bought a book for 6502 machine language. And then I had the basic Atari book for Atari Basic, which I already knew. I thought I knew Atari Basic pretty well. But that's really all I kind of had at my disposal. And of course, just researching some of those equations for coordinate transformations and things like that.
I think I have everything I need, unless you can think of anything else.
I think that's pretty much it. Yeah, it was like I said, it was an interesting project at the era when people saw that the telescope was controlled by an Atari. They were kind of surprised that an Atari computer can do that, but it was kind of fun. Yeah, I really much enjoyed it.
Great. Well, thank you very much, David.
All right. Thank you.
If you enjoy these interviews and would like to contribute, make a tax-deductible contribution to the Internet Archive, a nonprofit digital library that has done incredible things to preserve computer history. Make your tax-deductible contribution at archive.org/donate. Thanks.